For every hypothesis test we run, the first step is always going to be to list our information. When we run a hypothesis test for a single proportion, the first thing we'll list is p hat. This is our sample proportion. This is the percentage of people who feel a certain way or have a certain characteristic, and it's always in decimal form. So a good check is make sure p hat is always between 0 and 1. Next we'll list n, which is our sample size. And finally, we'll list p naught. P naught is our assumed value. That is, when we run a hypothesis test, we have something that we assume is true, or more likely something that we want to compare to. For instance, we might compare our sample to the general public, or a batch of things to the overall value we believe they should have. These will be the 3 things we list in our first step, so let's go ahead and do an example here. Now go ahead, pause the video a second, read through and make sure you understand it. This will be our first example dealing with military and government testing shenanigans. This was done in 1955, and essentially what we're looking at is cancer rates in a film crew versus the general public. Now I can tell I want to do a hypothesis test here, and I can tell because I want to know, can I conclude something? Hypothesis tests are about making conclusions, while confidence intervals are about making an inference about what range of values we might fall in. So if I want to make a definite conclusion here, I've got a hypothesis test. I can tell it's about proportions because I see a percentage here, and also because I have an out of. Those both cue me into the fact that I have a proportion, and once again, I want to conclude something, so I'm doing a hypothesis test. Now that we're certain of where we're going, I need to go ahead and do my first step. First step with every hypothesis test is to list. So I'll list p hat, I'll list n, and I'll list p naught. P hat is the percentage of people from my sample who felt a certain way. It's not the 13.6 because that's not talking about my sample, but rather the general public. My sample was out of the 220 people, so p hat for me will be 46 out of 220. When we run the test itself, we'll go ahead and convert this to a decimal, keeping 4 decimal places. Next, I need the sample size. That's 220 people. And then finally, p naught. I want to take these 220 people and I want to draw a conclusion about them. That is, I want to compare them to the general public, and since I'm comparing them to the general public, p naught will be that percent, or 0.136. 13.6% as a decimal, 0.136. Once again, p hat from my sample, p naught my comparison value, which in this case is what experts predict about the general public. Let's go ahead and do a second example just to make sure we got it here. Once again, pause the video, read through the example, and make sure you understand it. Here, we're going to go ahead and switch gears, and we're talking instead about twins and the chances that you give birth to them. Now, I can tell that I'm dealing with percentages here because I have the 7 out of 469, and I have a 3%, so it's definitely a proportion problem. I can also tell I want to do a hypothesis test because I want to know if I can conclude something. So I'm doing a 1 proportion hypothesis test here, which means my first step is to list. When I go to list, I'll list p hat, I'll list n, and I'll list p naught. P hat is the percentage of people in my sample who felt some way, and so it says here, in a study of teenage mothers, however, found that 7 of 469, so that's 7 out of 469 is what came from my sample. I'm going to be comparing this to the general public. So in 2009, approximately 3% of all births were twins, which means p naught is going to be 0.03. I'm comparing the percentage I have from my teen moms to the general public, 0.03. N is my sample size, which in this case is 469. So once again, in a 1 proportion hypothesis test, we list p hat, our sample proportion, n, our sample size, and p naught, our assumed value, what we're going to be comparing to.